So last class when we ended, we were talking about the distribution of how domestic household circuits happen. So we said that from the distribution company, your supply comes, then it comes to the meter box, right? The energy meter. And after that, it enters your house. And I said that this book will talk all about a single phase supply, but usually we have 3 phases supply. So I'll go by the book. So what I'll do first is that instead of drawing the whole house, I'm just drawing a straight line, which means that this is the boundary of your house, right? This is the boundary of your house. So, and before the boundary of your house, what do we have? We will, as I told you, we have what is called the energy meter. First, I'll go how the book is telling you, and then we will see how it actually happens. So the book says that it's a single phase supply. So we will have one phase wire which goes to the energy meter, and from the energy meter, it will get inside your house. Pretty correct? So whatever you consume out here, it will be billed at this section, right? And along with this, we should always have a neutral wire also. That is the return path of the current. So a neutral wire also comes, and the neutral wire also gets inside your house. No issues so far. And this is my energy meter. Energy meter matlab yaad hai na? This is going to measure all your kWh. How much kWh you are consuming. So the Discom company will come, take the reading every month. Nowadays, we have got very, very smart meters. Nobody needs to come. Like, do you think that in our Pebble City, everyone goes to every flat meter and he will not finish his job? So we can, there's a handheld device. You just connect the handheld device and all the meters will puke their data into it. We have even more smarter options than them. Like we have machines which are integrated with GPS. So these machines will automatically transmit the data on that particular day. So nowadays, nobody comes and takes a reading, okay? But as per your book, there's an energy meter where readings are taken, right? Then it enters my house. So this is my home. So in our home, just for your syllabus perspective, understand that all type of devices that you use in your home are distributed under 2 sections. All the devices based on the amount of current that they consume are distributed into 2 categories. One is called the as per your book, okay, as per your book, they are called the 5 amp category, and one is the 15 ampere category. Do you understand? All the appliances that we use are categorized under 2 types of current capacities. 5 amp, this does not mean that every appliance has to be 5 amp. It can be something less than 5 amp also. So current is something that a person consumes. So 5 amp kitchen for all those small kiddos, and for the big children and the adults, they will be fed from the 15 ampere kitchen, right? 5 ampere is the one which, for your understanding, is the smaller version of the plugs that you see, the small 3 pins. 15 amperes means the larger ones. So where have you seen this? You have seen this in geysers, microwave, washing machine, air conditioner, and all high current devices. Where have you seen this? Near your bedside table or your drawing lamp, all these, okay, the television and all. Anything which is high current capacity, right? Like for example, this particular UPS is a high current device. So if you see its plug is quite big, it goes inside a 15 ampere. Now, when we were small, it used to be known as 5 ampere and 15 ampere. This is what your syllabus speaks. But in actuals, if you go to the market now, these are called as 6 amperes, 16 amperes. So if you say to the shop that please show me a 16 ampere socket, he is going to show you a socket which will be with the big 3 pins. Show me a 6 ampere, so he will show you the small. If you say 5 ampere, he understands that you are on the old version. But sometimes have you seen some sockets where you have got the bigger ones also and the smaller ones also? So we call them combo. It's best to buy the combo, 16 as well as 6. So all these additional ones, look at this one. This is 16 and 6 combination. You can use it for a 16 and a 6. You can use it for a 16 only when the wiring has been done for 16. Okay, it's not about the socket, how the wiring goes. So these are the 2 categories. This is what CBSE tells you. So I would rather say that my 5 ampere caters to all low current devices. Low current devices. Sir, can you give us some example of low current devices? Lamp, fan, right? And these are the tube lights. These are all low current devices. And this caters to my high current devices. Okay, what are the high current devices? AC, geyser, anything which you are heating or cooling, simple. Refrigerator, then OTGs, oven, toaster, grillers, washing machines. These will be all high current devices. Understood? What the book doesn't tell you also is that once you are having high current devices and this wire has typically entered your house, you are not supposed to use the same category of wire for both, because what do we know? Heat developed in a conductor. Remember the formula? यही सबसे questions पूछ देगा आपको. The heat developed in a conductor is I square R T. T stands for the time for which you are operating your washing machine. You can't change the resistance of the washing machine. Time you can't change because you need it for a wash. And the heat developed goes square of the current. So that means if a device is pulling more current, the heat generated will also be more. So what should you do? You should actually try to work on a cable which are thicker cables. Okay. So usually the cables that we will use here, okay, the cables that we will be using for this particular wiring, the cables that we will be using for this particular wiring, and like this, there may be many sockets in my house. In kitchen, there may be 5, bedroom at least 2, living room 1. So all these will be with thicker wires. And this one will be done with comparatively thinner wire. So these we usually do something like 1 or, just for your knowledge, 1 or 1.5 square mm. Square mm means, did you understand? The cross-sectional area, mm square. And these we should do minimum 2 square mm. These are things which as engineers you should know better. An electrician, he has nothing. He will use the same wire out here. All the fires that happen due to electricity in shopping malls and other places are because they build shopping malls over old shops. Facade and everything they will develop, looks, but they will not work on the electricals. And all the pipes, cables run through a pipe. Cables are that old of 20 years. And the cable gets heated up, short circuit happens, fire takes place. People spend a lot on interiors. People become very miser if you say that this wire is a little bit costly. Budget nahi hai, isme kar lijiye. Nahi karna hai, wahi galti karte. Okay. Now let's see the other wiring. So the wiring goes like this, children. The neutral for everything is common. So this is a common neutral. Everywhere we will have a common neutral. This is a common neutral, and the neutral is then brought here. I've kept it here. Okay. So this means all the points have a common neutral. Understood? And all the points will have a common earth also. This is called the ground earth. And what happens to the earth? The earth wire ultimately comes, and there is what we call as a earth pit. There's a copper conductor which is actually below your soil. This is called the earth. And this particular green cable, this green cable is just connected to this. For every house, like if we are in titanium, my flat's green cable is continuous with her flat also, irrespective of the series. Everything comes and titanium will have one earth pit. We will see what is the utility of this, right? So have you understood this one? Now, in order to give protection, now we have to give some sort of protection to our devices. So what we have a MCB board out here, just like this board out here. This is an MCB board out here. And your book will say fuse and all. Nobody uses fuse nowadays. Why do we not use a fuse? A fuse is a headache. Every time a fuse blows up, you have to again replace the wire. So what we use nowadays are all MCBs, miniature circuit breakers. So there will be small circuit breakers, which in your normal language you call them as strips. And these strips are designed with various ratings, 6 amperes, 9 amperes, 20 amperes, 30 amperes. So typically how they will feed the wire? They'll feed the wire like this. This wire will come and connect here. Again, another parallel tapping here, again another. And all these supplies, these are low current, so we will connect with this. then these are high current. So these are high, this is a high current device. So I will connect this with 20 amperes. So do you understand what happens if this line pulls a current more than 20 amperes, say due to some overloading or something? This strip will automatically fall and protect all the devices that are connected to this stream. MCBs are very selfish. They protect equipment, not human life. Because it will trip when the current is more than 20 amperes. To kill you, how much do I need? 1 ampere. 0.8 amperes is sufficient to kill you at 240 volts. और ये ट्रिप कब करेगा? जब 20 एम्पियर, तब तक आपका चिकन रोस्ट हो चुका है. This, so the minimum, if I just open this also, I'll show you 6 amperes, 9 amperes. These current levels are good to protect the devices. Have you understood how it functions? Suppose you have done, suppose this girl Aparna has overloaded. In this plug, she has put 3-4 devices. And she is also running an OTG. वो extension cord होता है ना, उसमें सबने लगा दिया बेवकूफ की तरह. And then she is drawing more current. Once she draws current more than 6 ampere, there is a potential of fire. So this strip will automatically trip. Now what do? You will go and again try to reset it. That is the first mistake. It will never get reset because the fault has not been cleaned. First clean the fault. Say suppose I switch on a geyser and immediately it trips. You don't try to reset it again. It will never get reset. First disconnect the geyser because that is the criminal or the culprit. Disconnect the geyser and again engage it. This is as per your book. Have you understood how this thing happens? This is as per your book. But in the world of reality, it is not like that. Now we also should, now I just, because as students of science, you should know, and you are handling electricity every day, considering what has happened in our society once. Give me that 10 minutes. I want to tell you about how safe you are and how safety can be. That's why I brought that device also, just to show you. This is how it's in your book. A normal man's house will be wired like this. Your house is not wired like this. Your house has much more better protection than this. Okay, like, can we see any questions at this stage? Anyone? So have you understood? This concludes actually your syllabus. Your supply comes through the meter box, comes through a division of miniature circuit breakers. So all these, which you, and in your normal language you call them as strips. So these strips are then guided to, and the house is calibrated into two things called 16 ampere lines and 5 ampere. In your book it is 5 and 15. In reality it is 6 and 16 amperes. ठीक है, इतना ही. अब देखते हैं reality में how this thing happens in reality, and you should understand the concept of shock and earth. What happens in shock and what happens in earth. Electric shock is something that has not been dealt, but that you should always know. Okay, what is a electricity shock hazard? This is for your knowledge. And how the protection systems have developed over the ages. Every time you use a device which is metallic, you are risking yourself to a shock. Now just check what all metallic devices do we have. The electric iron is metallic. The computer is not metallic. The television is not metallic. These are all polycarbonate and acrylic body. Toaster and OTGs are metallic bodies. So let's see how we give the protection to a toaster. Let us say this is my toaster. This is my OTG. Okay, this is my OTG. Now how the wiring happens to the OTG? The OTG will typically have a plug. It has a plug where there are 3 pins. We know that this is the earth, and this is the live, and this is the neutral. So I'm now drawing it from this side. You will always see that the earth pin is bigger in size and the other 2 pins are smaller. Have you noticed? The earth pin will always be bigger in size. Okay. Now how the wiring happens? This earth pin is always connected to the body of the body. You can put a continuity tester here and here and it will beep. Any object, if you see that it has got 3 pins, the earth pin is always connected to the body, right? And then we have 2 more pins, the live taking the supply here and the neutral taking the supply here. This completes my connection. Now, if we go further, and as we learned, this is going to engage where? This is going to engage in this socket, right? And in this socket, the earth is again connected back right below your ground. Understood? Now let's say we have a user out here. We have a user out here. And the user is using what you call, this is how it used to happen in our childhood days. The user is using this particular oven. Due to some reason, this wire has lost its insulation and the hot wire has come in contact with the body. This hot wire has come in contact with the body. That means now the body has got live wire in contact with it. Are you understanding? So the moment this person goes and touches this OTG, fatal shock will happen. This used to happen in our childhood days. Okay. Now, once you touch it, once this person actually goes and touches this OTG, what will happen is that this person will receive a shock. Immediately shock will. Right? So how did protection happen in our days? Now look at here. The current is now, this particular current has now gone inside the body, and the current has two paths to choose. Path number one, it can go through the earth because the earth is connected, or path number two, it can go to the body of the person. Which side should the current go? The current will always go to the side which has less resistance. Human flesh, resistance is more. So the current will take the path of the earth, and the current will go below the earth, giving some potential chances of this person to have his life saved. But this is not guaranteed. ऐसा नहीं है. Because the resistance of my body may not be same as her body. She might be right now a little bit saline on her hand. I might have touched water. I might be a child. You might be an adult. Everything is different. But this was the only way that protection was given in those days. If you are using any sort of a device which is metallic. Have you understood? Now, another thing that can happen is that, let's say these two wires touch each other. This is called a short circuit. This is called short circuit. They will touch and huge current will flow to it. So what will happen? The fuse will blow off in our childhood days. In your normal days, what happens? The MCB trips. We are still not able to protect this person. Mind you, ये person अभी भी protect नहीं हुआ है. Because you are on a luck whether the current will go this side. Who knows? The current has both the path to go. If it goes for some 2-3 seconds into this person, it can cause fatal injury to this person. Are you understanding now? Next question that we ask in interviews also, we always ask, why is this longer in size? ये सब आपका life skills है. Why is this longer and why is this smaller? This is a sort of a protection. The earth is a protection. The protection should be the first one to engage and the last to disengage. Till the time you are disengaging it out, these two will first disengage और last में ये disengage होगा. It's like that mother. She will try to put the child on the bus. The child will still hold the shoulders of the mother. The mother will ensure that the child is now positioned himself or herself. At last will pull the two hands. जाओ बेटा ऊपर जाओ. यही is duty. That's why earth pins are always longer in size. First to engage, last to disengage. This is a protection. Modern flats and the flats where we are staying, ऐसा नहीं है wiring. इसमें हमने एक और intelligent device डाला है. अब वो device क्या है? That is the best part. That's what I brought it. But as I told you, modern houses have got 3 phases of wires comes in. Let's understand one phase is coming in. Okay, let's try to understand with one phase. So after your meter, this is your phase wire which is coming, and this is your neutral wire which is coming. Neutral wire, the current has to go back. The circuit has to be completed. Okay, this is coming and this has to go back always. So in modern houses, we will have a device out here. We have a device out here, and this device is known as an RCCB. Earlier it was, we used to use a ELCB, which is called an earth leakage circuit breaker. This is such a fantastic thing. Now you'll just love it. This is called RCCB, residual circuit current breaker. Okay, means residue in the circuit, if there is any residual current. Now we'll try to understand how this works. And then what happens? We have our network of wire which goes inside the house. It will first come through this and the wires will go through this. This is how it is. And your meter box is out here. Every flat in Pebble City is like this. Okay, only in Pebble City you have got 3 wires instead of 1, but I'm showing you through 1 wire, just like your NCERT book. Now we fit this device called RCCB. Now how does RCCB take care of your fatality. Now just see. The concept of RCCB is amount of current that is coming in through this side should be the same amount of current which should go out. If there is slight imbalance, how is the wire current coming? The current comes, you're drawing current in this way and the current is going out in this way. Do you agree? If 10 rupees comes inside, 10 rupees has to go out. If there is slight imbalance, this fellow will immediately trip. And these have got very high sensitivity. Their tripping is almost in the range of, 30 milliamperes. 30 milliamperes. Milliamperes means, are you understanding? 0.003 ampere. At what current will, and what is the voltage coming to a house? 240. At 240, a current around 0.8 to 1 ampere is sufficient to be fatal. 0.8 mein, it is fatal for you. This fellow has got a sensitivity of how much? 0.003. Means if there is a difference of current of 0.003 also, this fellow will trip. Now, how does that difference come? Let's see. Now, let's again draw our OTG. This is our OTG and this is the person, right? This is the person. Got it? So, we said that we will now create a little bit of short circuit in the OTG. Not short circuit, the OTG has got, the live wire got connected to the OTG. So once the live wire gets connected to the OTG, the current has a road to travel via the earth. Number one, the current also has a road to travel to the body of the person. And the neutral is connected. Now apply your common sense. Current came to the OTG. Say X amperes of current came to the OTG. After that, what happened? Current got lost this side as well as to your body. So if say X amperes came, do you think X amperes will return back now? No. There is a difference between these two lines. This RCCB trips immediately. In fact, in YouTube, there are videos where people will touch the live wire. Touch the live wire. The moment you touch it, it will trip. आपको शायद 1-2 सेकंड का शॉक लग सकता है. फेटल तो हो ही नहीं सकता है. फेटल हो ही नहीं सकता है. Kill that impression that you will be killed inside the flat in your houses is not possible. If somebody is doing his rumor, gossip mongering करता है, नहीं मर सकते हो आप. It is such an intelligent device. Cost of the device below 3,000. People don't buy. In these flats, this come inbuilt, and it will immediately trip. And the tripping is happening at what? 0.003. What is this difference with the MCB? The MCB trips at 6 amperes. The MCB is faithful to the product, not to you. This is faithful to you as well as the product. Current आगे जा ही नहीं पाएगा. Are you understanding? Yeah.
It trips. How does it come back?
Come back means you have to go and again set it back. You have to clean the fault. See, it can trip in, there are two ways it can trip. Suppose there is a defect in your television. It trips. Nothing of a headache for us. Disconnect the television and again set it back. Right? Our job is, forget the television, we can buy it again. What about the little kiddo in the house? उसने अगर जाके OTG को हाथ, right now the OTG that we have is having a current leakage in his body. Means if I put a tester on the OTG, it glows. So that's as good as death. If the kid goes and touches the OTG, the current immediately flows inside the kid, right? And the best part in our houses, why we say that always your earth should be good. Say suppose, let's say this kid is not there in the house at all. ऐसा करते हैं ना? इस बच्चे को अभी बच्चे ने छुआ ही नहीं है, बच्चा है ही नहीं. Today what happened? As soon as you have started your OTG, you find that the RCCB is tripping. That means what? Your OTG is having a leakage current. As soon as there is a leakage current, current will go through the earth. Let's forget the child. बच्चा को भूल जाओ. ये जैसे अर्थ में कोई भी करंट जाएगा, immediately आपका RCCB trip कर जाएगा. And to test your RCCBs in your house, maybe on a day like now, if you do, it will just take your 3-pin plug and take one test lamp. This is a test lamp, and take 2 leads out of it. 2 leads means one of the lead goes into the live, and one of the lead goes into the neutral. What happens? The bulb glows, right? Instead of doing the second connection this way, you just put the neutral out here on earth. So आप क्या करा रहे हो? आप करंट को अर्थ में पास करा रहे हो. ऐसा करते ही आपका आरसीसीबी ट्रिप कर जाएगा. This is a way to check whether your RCCB is working or not. So in our house, the RCCB as a device looks like this. This is your RCCB. So we have got 3 phases. So 1, 2, 3, and 1 neutral. You also, this is called a 4-pole RCCB. 1 pole, 2 pole, 3 pole, 4 pole. So if you are having a single phase supply, we will not buy this big product. We'll buy 2 pole. So यहाँ से current, the supply comes from here, and the entire house is fed from here. If it finds any imbalance between the 2 lines, ये साथ साथ ऐसे trip कर जाएगा नीचे, and you have to go and again set it back. And right now the trip switch will not work. If it is connected, to check whether your RCCB is okay or not, you can also do. घर में जाओ खोलो, ऐसा एक switch रहेगा. This is a different make. The ones we have are Schneider make. ऐसे दबाने से टक करके ट्रिप करे. अगर नहीं ट्रिप कर रहा है, you have a hazard in your house. Please replace this immediately. And generally these are excellent products. They will live more than your life unless you break it. Do that on Fleming's left-hand rule. करें question करने की कोशिश करता है. So imagine that I have a solenoid, and my solenoid is like this. ठीक है? I have a solenoid, and I will not say anything. Huh? The solenoid has been connected in this fashion. Understood? There's a maximum complicated question that you can get. Okay. And the next I say, a stream of chloride ions are made to travel top to bottom perpendicular to the solenoid. What should be the direction? Before asking this, I'll not ask this. Okay. Yeah, let's keep the question only till this much. Let's see whether you are. Where do you relate this question to? Abhi question aaya hi nahi. I have a solenoid, and the solenoid has been connected in this fashion. This question will go back to Fleming's left-hand rule. Fleming's left-hand rule has got an act. Who are the actors in Fleming's left-hand rule? FBI always. Yeah. So it is direction of. So we in Fleming's left-hand rule we have F, we have B, and we have I. Let's try to create those actors out here. Where do you see B out here? Around the solenoid. The solenoid will be creating the B, the necessary B. And we need the correct, you need to have the direction of the magnetic field. So how will you have the direction of the magnetic field? Let's see. Let's see.
Maybe
how do you understand? Let's see how the current is flowing. Try to see the current flow. How is the current flowing? Current is flowing from this direction to this direction, and then after that I'm using red color, otherwise you'll not be able to. Then in this direction, then the current flows in this direction, this, and finally the current is coming out in this direction, in this direction, in this direction, in this direction. Do you have any idea now how the magnetic field should be? Apply your knowledge. How do you find the pole? This is ultimately a magnet. A solenoid behaves like a bar magnet. Isn't it not a bar magnet? It's a bar magnet. Start thinking. So if it is a bar magnet, you need to first know where is the north pole, where is the south pole. How do you apply north and south in a solenoid? A solenoid is a combination of various loops. Stand to the solenoid in such a manner and try to see how the current is going. If you stand on this side, then you see that the current is going clockwise. And if that's the, you should see, if you are smart enough, you should try to find it with the way I drew the solenoid. On this side, how was our, what was the direction of my hand? Clockwise or anti-clockwise? Anti-clockwise. So if you see from this side, it's clockwise. So this has to be my south pole. Sorry, this has to be my south pole, and this has to be my north pole. Have you understood or not? Is this much clear or not? If this is north pole and if this is south pole, then I am good enough to draw the direction of the magnetic field. Is it opposite? But if you stand from this side, isn't the current coming out like this? You stand this side, try and see. The positive terminal is here. So how is the current going? Anti-clockwise. Yes, you are correct. So the current is going anti-clockwise. So hang on. So let's correct it. Okay, let's correct it. Are you sure? Let's check once again. How is the current going? Anti-clockwise. Clockwise is south. Anti-clockwise means this is north pole, this is south pole. So let us, what do? We change the direction of our, magnetic field. Is everyone with me? Are you able to understand? This is the magnetic field's direction. एक problem तो solve हो गया. This is B. Now we need to know the current. What is the other part of the question? Chloride ions. How are chloride ions? Chloride ions are Cl negative. Direction of current is always the direction a positive charge would move. These are negative charge, similarly like electrons. So the chloride ions are moving from where? Top to bottom perpendicular. That means current is going bottom to top. Very good. So shall we draw our diagram a little bit more simpler? This is my magnetic field. And how is my current, bacha? My current is in this direction. Let us name them now. This is B, this is I. Now put your Fleming's left hand rule and tell me which side it should drift. B and I. FBI. So B is in this direction, which is very good. I should be in this direction, this. So the chloride ion should come towards you. Very good. It should come away from the screen. How many of you understood this? This is a complicated question which you can get. All they are trying to test is whether you know what is chloride ion. If it is negative, do you know how to apply it with the direction of current? Do you know how the solenoid would work as a bar magnet? And then you go, देखो बच्चा ऐसे question आने से, first of all, always remember to apply Fleming's left hand rule, I have to have B and I have to have I. They could have juggled the case also. How do we juggle the case? To make it a little bit more difficult. A solenoid is wired in the pattern that has been shown, and it is observed that when chloride ions are made to move from top to bottom, they tend to come out of the screen. Nahin, they will say chloride ions tend to come out. Can you tell me in which direction the chloride ions are moving? So you have to basically then gauge force is on this side. Now use Fleming's left hand rule. Magnetic field is on this side. Force is on this side. That means current must be going upwards. But these are chloride ions. So the chloride ions must be initially going downwards. हाँ, ये question ऐसे आएगा. Free board में ऐसे ही question आएंगे. Anyone needs a repeat explanation of what I said? Don't hesitate. These are revision classes, and if you hesitate now, you will only not understand. Don't try to think that nobody's asking a question, so if I ask a question, I'll become an idiot. Nah. They will not tell you B, they will not tell you I. They will disguise these two things. The B will be presented in a manner which you have to figure out. Solenoid में ऐसे होता है. Current carrying conductor बोलेगा नहीं, तो ऐसे solenoid या फिर loop दे देगा. ठीक है? Yes. Okay, how to find I? So let's first understand the question in that case. My question would be like this. A solenoid has been connected in the pattern shown, and it is seen that chloride ions tend to drift away from the screen or from the paper, outwards from the paper. try and estimate the original direction of flow of the chloride ions. So chloride ions are drifting this side, means force is acting this side, magnetic field is acting this side. So this is my magnetic field. I align the magnetic field along the magnetic field. Fine. Force is outwards. So I twist my hand and I make the force outwards. Now where is my middle finger pointing? Exactly upwards. So the current must be in the upward direction. Right. Hold it. They have not asked you current. They are asking you how were the chloride ions moving. Chloride ions are what? Negative ions. Now negative particles movement direction is just opposite to the conventional direction of current. Now what you find out from Fleming's left hand rule is the conventional direction. So chloride ions. और यहीं पे अगर आपको बोलता मैग्नीशियम आयंस कैसा था, मैग्नीशियम आयंस होने से ऊपर की तरफ ही जाएगा बिकॉज दे आर पॉजिटिव. अल्फा पार्टिकल्स ऊपर जाएगा, बीटा पार्टिकल्स नीचे जाएगा. क्लियर हो रहा है? एबल टू अंडरस्टैंड नाउ? ठीक. ओके. Any question any child had? So with this what we'll do, we'll conclude this part of the chapter and then we will now, okay, I'm stopping the recording now.